Hi friends. So let's continue with our formula based solving of quadratic equations. So let us give you another problem, x squared minus 3. Here a is equal to 1. There is no x term, right? So b equal to 0 and the constant c is equal to minus 3. So what is the determinant? B squared minus 4ac. B is 0. So 0 squared minus 4. What is a? A is 1 and c is minus 3. So it's 12. Okay, so d is greater than 0, so you'll have two roots. What are the roots? Minus b plus square root of 12 by 2 or minus b minus square root of 12 divided by 2. Okay, that is either root 12 by 2 or minus root 12 by 2. Okay, but root 12 is square root of 4 into 3. So this 4, if you bring outside the square root, you will get 2 root 3. Okay, substituting, we get instead of root 12, you can substitute 2 root 3. So you'll get either root 3 or minus root 3. These are the two roots of this equation. Okay. What happens if you have only x squared? Only x squared means a is 1, b is 0, c is 0. So what is the determinant? Determinant is b squared minus 4ac. B is also 0. Minus 4ac, c also is 0. So you'll get a 0. So since d equal to 0, you'll get only one root. Okay, so what is that one root? One root is minus b by 2a. What is minus b here? Minus 0. What is a here? 1 divided by 2. So minus 0 divided by 2 is 0. So x is equal to 0 is the only root for x squared equal to 0. Okay, so this is a quadratic equation which has only one root. How about x squared plus 1? Here a is equal to 1, b is equal to 0, c is equal to 1. Right? If you take the determinant b squared minus 4ac, b squared is 0 squared, right? B is equal to 0, so 0 squared minus 4 into a into c. 4 into a is 1, c is 1. Okay, so 0 minus 4, you'll get minus 4. So d is less than 0. Therefore, equation x squared plus 1 equal to 0 has no roots. Because d is less than 0, it has no roots. Okay, now let's move on to cubic polynomials. Till now we have seen quadratic polynomials. Now let us see how to do cubic polynomials. Okay, cubic polynomials. Let's take an example. Show graphs for x cube minus 4x. See, this is a cubic polynomial. Why? The maximum, the power of the variable is 3 here. X cube, this is also a cubic polynomial. What about x cube minus x squared? This is also a cubic polynomial. Okay, now we will, for x cube minus 4x is equal to 0, you can take x common, right? And you can express it as x squared minus 4. What is 4? 4 is 2 squared. When I write 4 as 2 squared, this will look like a squared minus b squared, right? What is a squared minus b squared? Which is a plus b into a minus b, correct? So we can write this as x into x plus 2 into x minus 2. So to solve this equation, either x can be 0, then the left hand side will become 0, or x can be plus 2, at which point this term will become 0, so LHS will become 0, or x can be minus 2 also. So this equation x cube minus 4x is equal to 0 has three roots. One at x is equal to 0, one at x is equal to 2 and another at x is equal to minus 2. What about x cube equal to 0? Okay, it has only one root where x is equal to 0. When x is equal to 0, LHS will become 0. So it has only one root. What about x squared cube minus x squared equal to 0? Okay, if you take x squared common, you can write this as x minus 1. So this guy has two roots. Why? Because x can be 0 or x can be 1. In both cases, LHS will become 0, right? So the roots are x is equal to 0 or x is equal to 1. This has two roots. Okay. So now to look at how the curve looks, how the cubic curve looks, we have made a table here. Okay. Once you make a table like this, you can plot points and you can join the dots. Correct. So let's say x we consider minus 2, minus 1. This is the variable. So it can have any value. Minus 2, minus 1, 0, 1, 2. For convenience, we have taken these 5 values. Now, if you want to plot this first cubic polynomial x cube minus 4x, we have taken y1 as x cube minus 4x. So when x is equal to minus 2, what is x cube minus 8? Okay, what is and when you put x as -2 here, minus and minus, you'll get plus. So -8 plus 8, you'll get a 0. Okay, and when x cube is when x is -1, x cube is -1, and you put -1 here, right? -1 into -4, you'll get a 4, and -1, 4 minus 1, you'll get a 3. So you can calculate all these values. Similarly, when x is -2, what is x cube? It's -8. When x is -1, what is x cube? It is -1. So we have plotted these values also, and we have plotted for x cube minus x squared also. So after tabulating all these values, we have plotted it. For example, for the first one, -2, 0 is a point. So you can see -2, 0 is point number 1, point here. Can you see my pen where I'm pointing? That is 1 point. Okay, the second point is -1 and 3. So -1 and +3. Can you see this? We have plotted one more point. The third point is 0, 0. Can you see this? 0, 0. The fourth point is 1, -3. So when we come to 1, we go to -3. So this is another point. Next point is 2, 0. Can you see 2, 0 here? Okay. So this curve is x cube minus 4x. It cuts the x-axis 3 times. See, one cut, then it comes here, another cut. It comes here, another cut. It has 3 roots because it has 3 crossings of the x-axis. Whenever the curve of a polynomial crosses the x-axis, that means there is a root of the curve at that point. Okay, here for x cube minus 4x, the curve cuts the x-axis 3 times. Once at -2, so -2 is a root. Once at x is equal to 0, so 0 is a root. And another time at x is equal to +2. So x is equal to +2 is the third root. Okay, so when you plot for x cube minus x squared, you can see this curve here. Okay, this one, x cube minus x squared. This curve touches the x-axis only once at x is equal to 0, it touches it twice. Once at 0, x is equal to 0, and another time it cuts the x-axis at x is equal to 1. So it has 2 roots. Can you see the 2 roots? This curve at the bottom, it touches the x-axis at x is equal to 0, and then cuts the x-axis at x is equal to 1. So it has 2 roots. y2 is equal to x cube cuts the x-axis only once, only at x is equal to 0. So it has only 1 root. Okay, a cubic polynomial can have 0 roots or 1 root or 2 roots or 3 roots. Okay, and the graph looks something like this. Okay, so give a relationship between number of roots and the number of times the polynomial graph touches or cuts the x-axis. The fact is, for any polynomial graph, the number of times the graph touches or cuts the x-axis is equal to the number of roots that polynomial has. Okay, so previously you saw cubic polynomials. One touched the x-axis only once, another one touched the x-axis twice, another one touched the x-axis 3 times, giving 1, 2 and 3 roots. So look at this curve. It cuts the x-axis only once. You see this? So it has only 1 root. Look at this curve. It cuts the x-axis at 2 points, one here and one here. Just focus on the tip of my pen, one here and one here. So there are 2 roots. Look at this curve. It cuts once, then twice, then thrice. So there it has 3 roots because it cuts the x-axis at 3 points. This straight line cuts the x-axis at only 1 point, so it has only 1 root. This quadratic parabola touches the x-axis only at 1 point, so it has only 1 root. This curve of the polynomial cuts the x-axis at 1, 2, 3, 4 points. See here, 1 point, 2 point, 3 point, 4 point. So this has 4 roots. And this parabola does not touch the x-axis at all. Okay, so it has 0 roots. It has no roots. Okay, so number of times any graph cuts the x-axis, those are the number of roots that polynomial has or that equation has. Okay, give the relationship between roots and coefficients of a quadratic and cubic polynomials. Now it can be shown that if you have a quadratic equation like ax squared plus bx plus c is equal to 0, and if the roots of are alpha and beta, then you can show that if you add those roots you will get minus b by a, and if you multiply those roots you will get c by a. Okay, this you have to just remember. This is a proof given to you. You just have to remember that if you have a quadratic equation ax squared plus bx plus c equal to 0, and if the roots are alpha and beta, if alpha plus beta is computed, that will be equal to minus b by a. And if the roots product, this is the sum of roots, if the product of roots alpha beta is computed, that will be equal to c by a for a quadratic equation. What about cubic equation? Cubic equation is of the form ax cube plus bx squared plus cx plus d equal to 0. And there are three roots, alpha, beta, gamma. Correct? Now, if these three roots are added, it will give you minus b by a. If you multiply them in pairs and add them, so alpha, beta plus beta, gamma plus gamma, alpha, that will give you minus c by a. Sorry, just c by a, not minus. My apologies, just c by a. And if you multiply the three roots alpha, beta into gamma, alpha, beta, gamma, you'll get minus d by a. Okay, so these parts you have to, this information you have to remember. Let's do a problem. Verify 3, minus 1 and minus 1 by 3 are roots of, the polynomial 3x cubed minus 5x squared minus 11x minus 3, and verify the root and coefficient relationships. See, if you want to test a particular value is a root, you have to put that value in the polynomial and see if it results to 0. Okay, so if you take p of 3, okay, so 3 into 3 cube is here, minus 5 into 3 squared is here, minus 11 into 3 is there, and minus 3 is there. What is 3 cube? 3 3s are 9, 9 3s are 27, 27 3s are 81, correct? 81. And here 3 3s are 9, 9 5s are 45, minus sign is there. And here 11 3s are 33, minus sign is there, and minus 3 is there. Okay. Now 45 plus 33 is, you can see it is 78. Right? 78 plus 3 is 81. So you get a minus 81 here, you have a plus 81, you get 0. So 3 is a root of this equation. That is verified. Similarly, if you want to see if minus 1 is a root, you just substitute. So 3 into minus 1 cube, minus 5 into minus 1 squared, minus 11 into minus 1, minus 3. Okay. So what is minus 1 cube? It's minus 1. So you'll get a minus 3 here. Here you have minus 1 squared, which will give you a 1, but there is a minus sign here. So minus, you'll get a minus 5 here. So 11 into minus 1, you'll get a positive 11 here, and minus 3 is there. So 3 minus 3 is 6, minus 6, minus 6, minus 5, minus 11 plus 11, 0. Okay. So minus 1 is also a root. Similarly, you can verify that p of minus 1 by 3 is also the root of the equation. Now, let us check the relationships. If I add these three roots, that is 3 minus 1 and minus 1 by 3, LCM will be 3. So this will become 9. This minus 1 will become minus 3, right? And this minus 1 will remain as is. So my 9 minus 3 is 6, 6 minus 1 is 5, 5 by 3. If you take minus b by a, see this, b is minus 5. So minus b is 5. Okay. A is 3, minus of minus 5 by 3 is 5 by 3. You can see that you have proved that alpha, beta plus gamma is equal to minus b by a. So this is verified. Okay. Now let's verify the pairwise multiplication. Alpha, beta, beta, gamma, gamma, alpha, what it is? Alpha, beta plus gamma alpha is 3 into minus 1 into minus 1 by 3, minus 1 into 3. So 3 into minus 1, you'll get minus 3. Minus and minus, you'll get a plus 1 by 3 here. And here you will get minus 1 by 3 into 3, minus 1 you'll get. 3 is the LCM. So this will become minus 9, 1 and minus 3. Okay. So that will give you minus 11 by 3. Now what is C by A? Look at this. What is C? Minus 11. What is A? 3. So C by A is minus 11 by 3. So So you have proved that alpha beta plus beta gamma into gamma alpha is C by A. Okay. Similarly, if you multiply all the three roots, alpha into beta into gamma, you'll get 3 into minus 1 into minus 1 by 3. Minus into minus plus 3 will cancel, you'll get 1. And what is minus d by A? Minus d is minus of minus 3, which is 3. And what is A? That is also 3. So minus d by A, you'll get minus of minus 3 by 3, that is 1. So alpha beta gamma is equal to minus d by A, which is verified.